Hello and welcome to Unit 1 Part 4. We're going to identify the key parts of an expression and see components of terms to determine if operations can be performed. Before we do some examples, let's talk first about the parts of an expression. What you're given here is an expression. It says 3x squared plus 2x minus 5. And if you notice, it's not an equation because there's no equal sign, there's nothing to equal it to. So an expression is just adding or subtracting or multiplying or dividing of a bunch of terms, and we'll get into that more later. Some key parts. You may remember that the term without a variable, the number, is called a constant. Okay, the letters in algebra are called variables. They vary. They represent unknown values, and it's not always going to be an x. Sometimes it's y, sometimes it's a. It's a combination of many different things, but basically a variable represents some value that we don't know just yet. You may remember that the little number that's usually up and to the right of a number or letter is called an exponent. Or to the power is another way some people put it. The number that's in front of each individual term is often called a coefficient. And this one in the front here, this 3, is actually a very special one. It's called the leading coefficient when the terms are arranged in standard form with respect to the exponents being in descending order. Now I know I threw a lot at you and we'll talk more about that later, but the key parts at the moment, you need to know the constant is the whole number. The variable is the letter. The coefficients are the numbers that wind up in front of the letters. Exponent is the little small number in the top right. Some people call it a superscript. And then of course you have your operations of what's going on between each term. And notice that this particular situation actually has 3 different terms. There's a 3x squared term being added to 2x, and then you're subtracting 5. So there's 3 different terms there. So let's see if we can match these up real quick. It says the 3. Well, the 3 in this case is the number in the very front. This would be a coefficient. More specifically, it's a leading coefficient, but for today, we're just going to label that as the coefficient. The x, remember, represents the variable in this problem. We don't know what x is. The -5 is the number by itself over there. That's the constant. And this little 2 at the top with the arrow pointing to it represents the exponent. It means we're going to take that value of x and square it or raise it to the second power. Now let's talk about terms for a second. You'll hear this a lot in algebra. A term is a number, a variable, or the product of numbers and variables. And there's no separation by addition or subtraction, which means the term itself is the grouping by multiplication, the product of numbers and letters, basically, numbers and variables. Like for instance, 3x is its own term, 5x is its own term, okay? And this says up here that terms that are alike can be combined. Alike means they have the same sort of combination of variables. For instance, 3x plus 5x, those are both like terms. They both have an x value. So I can take 3x's plus 5x's and it will give me a result of 8x. We just combine like terms there. Take a look at the next question, and it's got 6a plus 2b minus 3a minus 7b. What you'll notice is that you can't combine 6a plus 2b. They are not like terms. So what I can do though is take the 6a and combine it with the -3a. They both have an a term. 6a's subtract 3a's from that leaves me with 3a's. Now let's move on to the next term. 2b can't be combined with the a's, but the 2b and the -7b are like terms. They both have the same variable. 2b's minus 7b's makes for a -5b. Very good. All right, moving on to the next one. We got a 4x squared plus 2x plus 3x minus 4. If I'm looking for another like term with the 4x squared, yes, these two have x's, but they don't have an x squared, so they're not considered like terms. That means my answer is just going to include the 4x squared as is. There's nothing to combine it with. The 2x and the 3x, however, are like terms. They can be added together. That'll result in 5x. And then the constant over here, -4, doesn't have anything else to combine with it. It just comes into the problem. Last one, this can be really tricky. If you notice all the letters, they get kind of jumbled up when you look at it real fast, but just take your time. 4xy squared. I'm looking for another xy squared. Look at there. Negative 3xy squared. They both have one x and they both have a y squared in the same combination there. Those two are like terms and we can combine them. 4xy squared minus 3xy squared is 1xy squared, but you don't have to write the 1. It's kind of an understood coefficient there. The next term to look at is the 2x squared y, and we do have a 10x squared. Well, they both have an x squared and then a single y. So those are like terms. 2 plus 10 makes for 12xy. Let me x squared y. All right, thank you for watching and hope it helps.